My dear students, welcome to Easy BTech, your guide for BTech and beyond. Our subject is Signals and Systems. Today's topic is Fourier transform. We will discuss this Fourier transform and very important topic. So all of you subscribe, share the channel, very useful to you. Let's start our session Fourier transform. So in the previous session we discussed about Fourier series. Fourier series is for representation of periodic signals. Fourier series is for periodic signals. Fourier series is for periodic signals. Periodic signals. Now Fourier transform is our topic. Fourier transform. So it is applicable for both periodic and aperiodic signals, this Fourier transform concept. We can use for periodic and aperiodic. Both periodic and aperiodic signals or non-periodic signals. Periodic signals. And another point is, the signals can be represented in two domains. We can represent signals in two ways or two domains. One is time domain. We can represent signals in two domains. One is time domain. Another is frequency domain. Frequency domain. Omega here, small t here. So conversion from time domain to frequency domain we can do with the help of Fourier transform. That is the point. So using Fourier transform we can convert time domain to frequency domain with the help of Fourier transform. Suppose if you want to convert frequency domain to time domain, conversion of signal from frequency domain to time domain, that is called inverse Fourier transform. Inverse Fourier transform. Right? So why we need to convert time domain to frequency domain? Because we can analyze systems and signals easily. Analysis of signals, systems easily. That is the purpose. In frequency domain we can analyze signals, systems easily. Okay. So analysis of signals and systems easily. Right? Now this Fourier transform is a mathematical formula or mathematical tool. So that formula we can derive from Fourier series. From Fourier series only we can get Fourier transform formula. So derivation of Fourier transform from Fourier series. Very important. So Fourier transform from Fourier series. So first I will take a periodic signal. Let xt of t is periodic signal with period capital T. It is a periodic signal with period capital T. Capital T. And we can represent periodic signal. How to represent periodic signal? Using Fourier series. So we have exponential Fourier series. We have exponential Fourier series. What is the exponential Fourier series? Already we know the periodic signal xt of t can be written like summation n is minus infinite to plus infinite, Cn e to the power jn omega naught t, e to the power jn omega naught t. So here omega naught is 2 pi by t, omega naught is 2 pi by t, and here Cn coefficients, Fourier series coefficients, Cn is equal to 1 by t integral minus t by 2 to plus t by 2, or we can take 0 to t over one time period, minus t by 2 plus t by 2 or 0 to t. So the signal, periodic signal xt of t into e to the power minus jn omega naught t dt. So this is the coefficients, Fourier series coefficients, exponential Fourier series coefficients. Okay, so this we have for periodic signals. Now Fourier transform. So what I am doing here, the time period t tends to infinity if time period is goes to infinity. This is the point we are considering. If time period goes to infinity, the periodic signal xt of t will become a periodic signal x of t. This is a periodic signal, this is a periodic signal. The periodic signal will become a periodic signal. Next, and here the discrete frequency n omega naught we have. N omega naught, it is 1 omega naught, 2 omega naught, 3 omega naught, discrete frequency. It will become continuous frequency omega. So this is the second point. The discrete frequency will become continuous frequency. Okay, and here omega naught, it is 2 pi by t. As the t goes to infinity, as the t increases, this omega naught will become very small, right or not? So omega naught will become d omega, very small, because t is going to infinity, right? So all these modifications or all these changes we are going to substitute in coefficients formula, So what is the point here? As the t tends to infinity, this is the point, time period goes to infinity, periodic signal will become a periodic signal, which is x of t, n omega naught will become omega, and omega naught will become d omega. So all these we are going to write in Cn. So Cn is equal to, first we take that limit t tends to infinity, 1 by t integral minus t by 2 to plus t by 2 xt of t into e to the power minus jn omega naught t dt. So let's apply this t tends to infinity. So I am bringing this capital T left side, then t into Cn is equal to, take the limit t tends to infinity, then integration limits minus infinite plus infinite, right? And this xt of t, the xt of t is a periodic signal, will become a periodic signal x of t, okay, into e to the power minus j n omega naught. So what is n omega naught will become omega, continuous frequency omega t dt. Okay, now the right side one, this integral I am taking as capital X of omega. The right side integral I am taking as capital X of omega. This is t into Cn is equal to. So where what is capital X of omega? The integral we have. So where the capital X of omega is equal to integral minus infinite plus infinite x of t into e to the power minus j omega t dt. So this is called Fourier transform of x of t. What we call Fourier transform of x of t. Okay. So this is a way of representation of Fourier transform pair. So x of t Fourier transform is capital X of omega. So Fourier transform that converts time domain signal into frequency domain signal. After Fourier transform we get the answer, that is capital X of omega in terms of omega. Omega is the frequency. Okay. Now still we are going to see inverse Fourier transform formula. This concept will continue again. So this is the Fourier transform pair. Fourier transform of x of t is equal to capital X of omega, right? And which is equal to integration minus infinite plus infinite x of t to power minus j omega t dt. This is the Fourier transform formula. Let's see continuation of this. So we know the periodic signal xt of t is equal to summation n minus infinite to plus infinite cn e to the power j n omega naught t, right? As the t goes to infinity, as the t tends to infinity, so this periodic signal will become a periodic signal. So xt of t will become x of t, right or not, is equal to, and the summation also will become integration. Summation becomes integration. So integration right side minus infinite plus infinite, and here cn, already we know that t into cn is equal to capital X of omega, right or not, already we have seen this. So cn will become x of omega by t, x of omega by t, and t, what is t here? Omega naught is equal to 2 pi by t, right? Omega naught is 2 pi by t. So 2 pi by t, from this t will become 2 pi by omega naught. So that I am writing here in the place of t, we can write 2 pi by omega naught. So in the place of t, 2 pi by omega naught. Okay, and here e power j n omega naught will become omega t, and here we have omega naught, and already we discussed that this omega naught will become d omega. Omega naught will become d omega, very small. So in the place of omega naught we can write d omega. So all the things, when t goes to infinity, all the things I substituted, I have taken. So what we got, that will be called inverse Fourier transform. X of t is equal to 1 by 2 pi, we can write outside. So integral minus infinite plus infinite capital X of omega e to the power j omega t d omega. So this is saying frequency domain to time domain. Inverse Fourier transform. This is called what we call inverse Fourier transform. Right? So simple formula. This is the inverse Fourier transform formula. Okay. So the formula is derived from Fourier series only. In Fourier series, what is the concept we are taking? Time period goes to infinity, t goes to infinity. This is the point. As the t goes to infinity, then what are the changes? All those we have taken into consideration. Then we got the formula, Fourier transform formula and inverse Fourier transform formula. Right? Now, Fourier transform of, let's do some examples. Fourier transform of unit impulse function, that means del of t. What is the Fourier transform of unit impulse? Del of t. Important. So we know first Fourier transform formula, right? That formula. What we know? What is the Fourier transform? Fourier transform of x of t is defined as, or is, so we can represent like this: Fourier transform of x of t is equal to capital X omega is equal to integral minus infinite plus infinite x of t into e to the power minus j omega t dt, minus j omega t dt. So what is the given x of t here? Given x of t is del of t, impulse function, unit impulse function. So take that in the place of x of t, that is del of t e to the power minus j omega t dt, right? So here we know already multiplication here, del of t into e power j omega t. So any signal x of t multiplied by del of t, the result is x of 0 into del of t. So simply here take the bracket t is equal to 0, this t is equal to 0, we keep in the beside function x of t or whatever it is. So x of 0 into del of t, same concept we go with. So integral minus infinite plus infinite del of t into, so del of t is as it is, into x of 0 means e power here minus j omega t, so e power minus 0 dt. So e power minus 0 or plus 0, it is 1. So this will be integral minus infinite plus infinite del of t dt. So this integration represents area under impulse, right or not? This integral is area under impulse, so which is equal to 1. Area under impulse is 1 always. Then the answer is 1. So what is the Fourier transform of del of t? So Fourier transform of del of t is equal to del of omega is equal to 1. This is the result. So this we can plot, we can show. The Fourier transform converts time domain signal into frequency domain, right? So first, this is the time domain signal. In frequency domain. So here x-axis t, the given signal del of t. So this is the del of t. After Fourier transform, del of omega, which is equal to 1. So draw a line 1, constant line 1, and here x-axis is omega. So conversion from time domain to frequency domain. Fourier transform of impulse, unit impulse is 1. That is the answer. Okay. So draw a line 1. Clear? So we have next session continuation of Fourier transform of elementary signals. Unit impulse is completed. We got the answer 1. Next we do other signals or elementary signals. So thank you students. Please share the channel. Thank you.